Hello everyone, welcome to Hydropower. Today we will be talking about the precipitation, water from the sky. So, let's start the season. Precipitation impacts our environment in numerous ways. It allows plants and animals to thrive, sculpts our landscapes, and keeps our water reserves replenished. Let's explore the causes, forms, types, and measurement of this fascinating process. The causes of precipitation: cooling of air masses. As air cools, it becomes saturated and loses its ability to hold moisture, leading to precipitation. Formation of clouds due to condensation. Clouds form when air cools and reaches its dew point, causing water vapor to condense around tiny particles. Growth of water droplets. Cloud droplets grow when they collide and merge within clouds, a crucial step in precipitation development. Accumulation of moisture. Moisture accumulates in the atmosphere through sources like evaporation from water bodies. When this moisture-laden air encounters cooling and condensation, it can result in precipitation. Collision and coalescence. In warm clouds, precipitation often occurs through collision and coalescence. Water droplets collide and merge with each other to form larger droplets that eventually fall as rain. The forms of precipitation. Precipitation comes in various forms, depending on temperature and atmospheric conditions. The primary forms of precipitation include rain, liquid water droplets that fall from the sky when temperatures are above freezing; snow, ice crystals or snowflakes falling from the sky, occurring when temperatures are below freezing; sleet, frozen raindrops or ice pellets that form when raindrops freeze before reaching the ground; hail, large pellets of ice formed in severe thunderstorms, ranging in size from small pellets to golf ball-sized or larger; freezing rain, rain that falls when temperatures are below freezing and freezes upon contact with cold surfaces, creating a layer of ice on the ground; drizzle, light raindrops with a very small size, often resulting in fine and misty precipitation. The types of precipitation. Precipitation can be categorized into different types based on its characteristics and the processes involved in its formation. Here are some common types of precipitation. Convective precipitation. Results from the upward movement of warm, moist air, often appearing as heavy, localized rain showers or thunderstorms with intense, short bursts of rainfall. Orographic precipitation. Associated with the lifting of moist air over elevated terrain, such as mountains. It leads to consistent and often heavy rainfall on the windward side, creating a rain shadow on the leeward side with less precipitation. Frontal precipitation. Occurs at the boundaries between different air masses. When warm air meets cold air, the warm air is forced to rise over the denser, cold air, causing condensation and precipitation. Frontal precipitation can be steady and prolonged. Cyclonic or cyclone-induced precipitation. Associated with low-pressure systems like cyclones or depressions, bringing widespread and sustained rainfall as they move across a region. Convectional precipitation. Convectional precipitation is linked to rising air, usually due to daytime heating. As the air warms, it becomes buoyant and rises, leading to the development of cumulus clouds and, eventually, thunderstorms with heavy rainfall. Non-frontal precipitation. Non-frontal precipitation refers to precipitation that is not associated with the passage of a weather front, which is a boundary between different air masses with varying temperature and humidity. Instead, non-frontal precipitation typically occurs due to other atmospheric processes and conditions. Measurement of precipitation: tipping bucket rain gauges. Automated instruments that collect rainwater in a small bucket. When a specific amount of rainwater accumulates, it tips over, and the count is recorded electronically. Weighing precipitation gauges. Measure both rainfall and snowfall by collecting precipitation in a container and measuring the weight of the water or melted snow using load cells or strain gauges. Natural siphon rain gauge. Uses a siphoning mechanism to drain collected rainwater from a funnel into a measuring container. The depth of the collected water is manually recorded at regular intervals to determine the amount of precipitation. Float-type rain gauge. Designed with a float that rises as rainwater collects in a container. The height of the float is observed and recorded manually, proportional to the amount of rainfall. Non-recording type measurements. Methods that require manual readings or observations at specific intervals, without automatically recording the amount and timing of precipitation. The impact of precipitation. Precipitation has a considerable impact on our planet's habitability. It provides the water necessary for life, agriculture, and industry while shaping our landscapes, rivers, and oceans. Adequate rainfall is essential for balanced ecosystems and helps regulate global temperatures. Droughts, floods, and landslides are natural hazards commonly associated with precipitation patterns, making a proper understanding of precipitation's dynamics and measurement critical to preventing and mitigating their effects. Precipitation statistics: world's rainiest place. Mawsynram, a village in India's northeastern state of Meghalaya, experiences the highest annual average rainfall on Earth, averaging over 467 inches of rain each year. Global precipitation. Over 505,000 cubic kilometers of water evaporate from the Earth's surface annually, with over 90% of it returning to the surface as precipitation. Precipitation extremes. The largest 24-hour rainfall record is held by Foc Foc, La Réunion, with a total of 1,870 millimeters of rainfall on March 15 to 16, 1952. Precipitation and climate change. Changing global temperatures influence precipitation patterns worldwide. As atmospheric temperatures rise, the amount and type of precipitation may vary, causing intense storms, droughts, and heatwaves in different regions. Precipitation extremes like hurricanes and typhoons can become more likely with climate change, causing widespread damage and loss of life. Predicting and adapting to precipitation changes is becoming more critical than ever. Conclusion. Precipitation is a dynamic process, shaping our planet in countless ways. Understanding its causes, forms, types, and measurement methods is crucial to comprehend our environment's intricate dynamics. As we face challenges like climate change and extreme weather events, a deeper understanding of precipitation's role is becoming increasingly essential. For today we end up the season with this much. We will come again with brand new videos. Till then, keep on watching our videos and don't forget to subscribe our channel. Thank you.